Hey guys, in this video we're going to be covering target 3A.1 and we want to be able to eventually add, subtract, and multiply complex numbers, but before we can even get there we need to be able to identify a real and what is a complex, as well as being able to simplify things that do have imaginary numbers in them. So what is an imaginary number? Imaginary number is the square root of a negative number. The reason why we have that imaginary there is because we cannot take the square root of negatives. So the imaginary, that I, is because you cannot take the square root of negative numbers. So when we see that, for example, square root of -1, we cannot take the square root of negative. So that is why we replace it with what that, imaginary part, we see that little I. Likewise, if I have an I squared, that is still imaginary. When we take the square root of that and square it, actually, what we're doing, what that actually simplifies to, is if I know that I is the square root of -1, I have to square that. When I square the square root of -1, what my answer is just -1. So anytime you have an I, it's the square root of -1. Anytime you have an I squared, it's just -1. All right, so let's go ahead and kind of scroll down here so we can get to the complex part. Complex numbers just means that there's a mixture of both imaginary and normal numbers. So if I am asking you what the real part is the A, right? And A is a constant. And remember, a constant is just a number, no variables. Alright, so again, A is the constant part. The imaginary part is whatever has the I attached to it. So that's going to be BI, right? It's going to be where B is a coefficient. A coefficient is just the number in front of that variable. So to kind of remember this, when we see that imaginary I, that I part, that's the imaginary part that I'm asking you to find. If I just have a constant, so no variable, nothing special, it's just a number, that A is the real part. All right? So let's kind of practice some of these. When I look at these examples down below, it's have the square root of -36. Do not even bother plugging that in your calculator because of the fact that you will get an error because your calculator says you cannot take the square root of a -36. Alright, so what we have to do here then is we have to break this down. I'm going to rewrite this. I want to remove that negative. So -36 is the same thing as saying 36 times a -1. Alright, when I have that negative, we have to be able to remove that and now replace it with an I. So if you need to take the square root of 36 in your calculator, please do that. I'll pull my calculator up now. Alright, so on my calculator, I'm going to go ahead and press Control X squared, type in my 36, Control X squared, type in 36. What's going on with my calculator? Let's try it again. Control X squared. There we go. When I type in 36, I get 6. So what that tells me then is, well, square root of 36 is 6. And the square root of I, like we said above, when we have that square root of -1, that changes to an I. So I have 6I. And anytime you take the square root, you always have a plus or minus sign. So you can have the positive 6 times 6 or a -6 times a -6. So that is also something, anytime you take the square root, right? You need the plus minus sign. So that just means that you're accommodating for both the positive and negative version of 6. That I come from the square root of taking a negative. All right, so let's try another one. I have the square root of a negative 25. Again, if I were to plug in a negative 25 in my calculator, it comes up as an error. So I have to kind of break it up before by saying 25 times a negative 1. Hopefully we kind of more familiar with those square roots of negatives, or, perfect squares. But if not, you could use your calculator. So press Control X squared, type in 25, and, oops, I only put 5. Square root of 25. It doesn't like the 2. So 25, which is 5. Right? And then again, if you can do that in your head, that's amazing. I cannot forget that plus minus sign in front. Bring down my 5, and again, that square root of a negative becomes I. So that's my final answer, plus or minus bi. If I get to the next one, square root of a negative 100. Hopefully you start seeing these patterns. I'm going to separate these to be 100 times a negative 1. Square root of 100 is a plus or minus 10. Again, check it in your calculator if you need to. The square root of that negative 1 is going to be just I. Should just be I. Alright, now if I were to ask you, what's the real part, what's the imaginary part? The imaginary part is whatever has the I in it. So my imaginary part is plus or minus 5i, plus or minus 10i, plus or minus 6i. There is no real part because there's nothing in front of that plus or minus sign. Alright, kind of keep going. If I have the square root of a negative 81, I'm going to break that up and say that this is going to be 81 times a negative 1. Square root of 81 is a plus or minus 9. Yes, you need both versions, so you do need that plus minus sign in front. The square root of a negative 1 is I. That is all the imaginary part. If I have a negative, look at what's underneath the square root. Do I have a negative under the square root? No, I do not. So what I'm going to do is kind of put yourself a little asterisk here. There is going to be no I. Why? Because, I'm going to abbreviate here, because the negative is not under the square root sign. My goodness. So what that says is no I because the negative is not under the square root. So what I'm going to do here is bring this negative down. The square root of 9 is just 9. Okay. Alright, so that's all I have to do. If there's no negative underneath it, you don't need to combine it anyway. There's nothing to change. Negatives on the outside. Number 6, I'm actually going to skip number 6. Don't worry about number 6. We can kind of jump over number 6. You're not going to see something where you have a negative both inside and outside. So let's just finish up the last 3 examples. Square root of a negative 48. What we want to do here is we want to break up that negative. So 48 times a negative 1. But when I take the square root of 48, that's not a perfect square. So when I see this, square root 48, it's not going to be a perfect square. We're going to get a decimal, right? So what we need to do is go back to that multiplication chart. We want to find those factors that can break down 48. That is a nice perfect square. So when we look at that multiplication chart, you should still have yours from the last unit. And what we end up breaking down 48 to be, the biggest perfect square is 16 times 3. So 16 times 3 is 48. 16 is that perfect square, but we still can't forget that we're multiplying by that negative 1. So when I rewrite this, taking the square root of that perfect square, this square root of 16 ends up being my plus or minus 4. There is no perfect square of 3, so I'm going to bring over, or actually bring down my square root of 3. And the I, this is kind of, a little bit tricky. That I does be, or square root of -1, that is an I, but the I goes in front of the square root. So not in front of the 4, just in front of whatever the square root is. And again, that's all imaginary. All of that is getting multiplied together. Looking at number 8, I would like to break that up as much as possible. 32 times the square root of -1. If I check the square root of 32, that is not a perfect square. So again, go to your multiplication chart. Try to find that biggest perfect square. And what we see is that 16 times 2 gives us 32, and 16 is that perfect square. Again, I'm not going through that because that was in the previous video. So if you need to look back, please look back at the notes from the other unit. So square root of 16 is going to give me that plus or minus 4. There is no square root of 2. And again, that square root of I, or the square root of -1 is I. I keep saying that because it's already, my brain's working too fast. So my final answer would be plus or minus 4i times the square root of 2. Alright, last one here. Breaking that down would be 45 times a -1. I want to check to see if 45 is a perfect square, and it is not. So I would go to my multiplication chart, try to break that down into something that is a perfect square, which would be 9 and 5. Don't forget, I'm still multiplying by -1. When I take the square root of 9, that's a plus or minus 3. Bring down my square root of 5 because that's not a perfect square. And that square root of -1 becomes I. So I'm going to bring that down into my final answer. Alright, go ahead and give these a try. We should be able to just take the square roots of negatives and positives and be able to see where we have an I and where we do not. Again, if this negative is not under the radical, you should not have an I in your answer. Alright, go ahead and give this a try. You should be working on 3A.1 activity. Good luck.